All right, guys, we are going to be starting linear inequalities. Okay, so for each of these, they're obviously still going to be a straight line since they are linear inequalities, and then they're obviously going to be an inequality less than, greater than, equal to, or more than or equal to. So on this first graph, we're going to graph y is greater than or equal to negative 1 over 4x minus 1. Okay. Now we have to think back to solving inequalities from before, and whenever we would have less than or greater than, or the other way around, greater than or less than, it would be an open circle, okay? If it's equal to, it's going to look different, okay? Same thing's going to apply here. But the first thing we're going to do is we're going to graph the points. So graphing is still the same. This is still my y-intercept. This is still going to be my slope. So I'm going to go through and I'm going to graph each of the points. So my y-intercept is at negative 1. It's a negative slope, so I'm going to go down 1 and right 4, or up 1 and left 4. And that's the most that I can get on the graph there. If I could do it again, I would. Okay, but since I can't, then it'll stay like that. Since it is a greater than sign, it is going to be a solid line. Okay, so we're going to connect this just like normal. Extending off of our graph, arrows on either end. Now the difference here is because it's greater than, we could have a variety of possibilities. Remember, whenever we would solve inequalities, we would have to graph on the number line because it wasn't just x equals 2 or x equals 5. We had to show on that graph all of the possible solutions. The same thing applies for linear inequalities. The only difference is we have to test a point. So what you need to do is you need to pick a point on either side of your line. It does not matter which point you pick. So let's say I'm going to pick this one right here. Okay. You are going to test that point. So that point is negative 2, positive 3. You are going to see if negative 2, positive 3 is a solution to this inequality. So you're going to plug the x value in, plug the y value in. So let's see, the y value is 3. Negative 1/4 times negative 2. Is 1/2. 1/2 minus 1 is negative 1/2. So right now, I need to decide whether or not this is true or not. Is 3 greater than or equal to negative 1? Yes, it is, right? So that means that negative 2, 3 is a possible solution, okay? We could test every single point on this entire graph, but we don't need to. We only need to test one. Okay, you will then shade on whichever side of the graph all the solutions fall. So since this was a yes, this works for this equation or this inequality, we will shade on the same side as that point. If this would have come out and been not true, we would have shaded on the other side of the line. So all of these points in here are possible solutions to this inequality. We can plug any of those points in and it'll work. The left side will be greater than or equal to the right side. All right, let's try another one. All right, let's do y is less than 2/3 x. So the y-intercept here would be 0. Positive slope, so up to over 3, up to over 3, up to over 3, down to over 3, 2 over 3. Now since this is not an equal to, it's going to be a dashed line. So this is why it's extremely important that you go off of your graph paper. Because if I can't tell whether or not it's a solid or dashed line within your graph, I'm looking over here off of your graph to see whether or not it's dashed or solid. If I can't tell, I'm counting it wrong. Okay, so it should be perfectly clear whether it is dashed or solid. All right, now you need to test a point on either side. Since I already accidentally put that point in there incorrectly, I'm going to go ahead and use that. So that point is +2, +3. So for y, I'm going to plug in 3. For x, I'm going to plug in 2. You can pick any point on either side of this line. So 3 is less than 1 1/3 or 4/3. Is 3 less than 1 1/3? No. Okay, no. So that means this point and any point on this side of the line will not work. So I need to shade on the opposite side of the line. If you want, you can always test another point in the area that you're shading. Okay. Work-wise, I must see what point you tested. So you need to put the point, you need to write down the point you tested. You can write it off to the side. I have to see this. I have to see all of that work. All right, I want you to pause it and try this one on your own and then come back and see if you got it right. All right, so I want you to try this inequality. Pause the video, you do it on your own, and see if you're right. All right, so that's the line you should have graphed. Should be solid. I am testing the point 1, 1. I plugged it in. My statement is 1 is less than or equal to 2 1/5, which is correct. So I'm shading on the same side as that point since it worked. All right. We're going to do the exact same thing on the back problems, except for now they're going to be in standard form, okay? And the only difference here is we have to change them to slope-intercept form before we can get started. Remember that the one thing that you have to remember about inequality is that if you're dividing by a negative, you still have to flip the sign. So -3x to the other side, -4y minus 3x plus 4, divide by -4. I divided by a negative, so I have to flip my inequality. So I have 3/4x minus 1. So that's what I'm going to be graphing now. So graph that. Okay, since it is a less than or greater than sign, it will be dashed. Got to pick a point to test it. Let's pick this one. 1, 2, 3, 4. So I'm going to pick 1, 5. You don't have to pick that. It's just the one I'm choosing to pick. So 5 is greater than -1/4, which is true. So I'm shading on the same side as my point. All right, let's do one more. And then if you need to go back and watch or listen to any of this, you can do that. But I'm only going to do one more example. So switch it. We divided by a negative, so I have to flip the sign. So I have 5 over 4x plus 3. Solid line. Oops. I'm going to pick this point right here. So what's that? Negative 4, 3. And you can plug it back into the original one. I probably should have plugged it back into the original one, just in case my math was wrong, because even if my switching is wrong, I could still end up with the right answer, possibly. Three is greater than, oops, not greater than. 3 is less than or equal to negative 2, which is not true. So I need to shade on the opposite side. All right, if you need to go back and watch the video again, okay, look over the examples again, you can. Okay, but you need to raise your hand and show the sub your notes. That way you can get your worksheet, and you need to be working on that the rest of the hour.